Good afternoon, sir. Good afternoon, everyone.
Good afternoon, ma'am.
Good afternoon, sir. Good afternoon, madam.
नमस्कार नमस्कार मॅडम नमस्कार.
So we can start in another 1 or 2 minutes. Ma'am, Professor Gupta is joining in a while, so we can start. Sir, Kadaswamy sir, are you here?
Madam?
Ji sir.
Yes, madam. Madam, just a moment, madam. Our friend.
Okay, okay. Good afternoon, everyone. A very good afternoon to all. So, welcome all of you to the 3 days online training program on disaster risk reduction and management in agriculture and food safety. So we will be conducting this training program from 28th March to 30th March 2022, and timings will be 2 p.m. to 5 p.m. So we will have so many resource persons speaking on various aspects of agriculture being affected by disasters. So first of all, I would like to invite Professor P. Kandaswamy sir for setting the context of this training program. So, sir, you're most welcome.
Thank you, madam. Good afternoon, all of you. Welcome to all the resource persons, participants, and welcome to our course directors, Professor Anil Kumar Gupta. But he has some other work, so that he could not join now. And course director, Professor Arun Kumar Barik, Principal Palli Siksabana Viswabharati. He is going to join now. So by the time I will going to give welcome address. Welcome to all. So this training program, 3-day online training program on disaster risk reduction and management in agriculture and food safety. So this program will be conducted by Department of Agriculture Engineering in collaboration with National Institute of Disaster Management, New Delhi. So this will be from 8 to 30. Madam, one. Madam, principal is calling. Welcome, madam. Actually, our principal and he has some other administrative work. He could not join in this meeting. So just now he informed me. So we will proceed from our side.
Sure, sir. Sure, no problem.
Okay. So in this program, for 3 days program, there will be 9 lecture per day. First day 2 lecture, second day 4 lecture, and the third day 3 lecture. So 9 speakers from well-known speakers from various university. They're going to deliver on disaster management and food safety. So in this introduction, we will invite our speakers, and thank you for participant in this program and registration for next 3 days. All of you go ahead, and this program will be very useful for participant, even students, related to disaster management and food safety during disaster management. So this will be helpful for participants. And also, I am very much thank you for National Institute of Disaster Management when I am approaching the proposal on this 3-day program. Within 1 month, the institute has approved our proposal, and also from the beginning, I conducted our course coordinator, Dr. Kokol Verma, and since beginning, she was very much helpful as to join this program. To conducting this program, and at various aspects she helped for this. So I welcome to all to success the program for next 3 days. Thank you, madam. Madam, any other one like to convey, madam, for your side?
Thank you very much, sir, for giving a brief introduction of the training program. So maybe when Anil sir and principal sir both are available, maybe we can have the inaugural later at the second day or so. So, sir, I think we can go ahead with the lectures. So, sir, would you like to invite our first speaker of the day?
Yes, madam. So, madam, today there will be 2 lectures. Will be given by Dr. Lala Iswari Rai Prasad. So, and he is working as associate professor in soil and water conservation engineering at a College of Postgraduate Studies in Agricultural Sciences and Central Agricultural University. His degree in agricultural engineering from Odisha Agricultural University and and he pursued his master degree in water conservation in Agricultural University, Coimbatore. His doctoral degree was from IIT Kharagpur. Apart from this regular degree, he is an awardee of postgraduate diploma in disaster management from Indira Gandhi National Open University. He also worked as an emergency cum agriculture officer in livelihood restoration project funded by DFID under United Nations Orissa Shell. He is a fellow member of Institution of Engineers India and Indian Water Resource Society, Roorkee, and he received of Best Student Award from TNA Coimbatore. Dr. Ismail Siragdalin Award from TNAU Coimbatore for Best Student in SWCE. He is also awardee of Israel Government Fellowship for doing his highest research work at Flat Israel. Presently, he is working on water poverty related issues, resource conservation techniques for enhancing crop productivity in a northeastern hill region. So with this introduction, I am inviting Dr. Lala Iswari Rai Prasad to give a lecture on disaster management strategy in agriculture, planning and adoption of alternative cropping system.
Hello, thank you.
Lala, I invite you.
Okay, thank you. Let me share my slide first. I hope it is visible.
Yes, sir. Can you start your PPT? So we
Yes,
can see. Yes.
I have shared my PPT. I hope it's visible.
Yes, sir. It's visible. Can you make it full screen?
Is it okay?
It's coming. Yes, sir. It's fine now.
Okay, my voice is audible, I think.
Yes, sir. Perfectly audible.
Okay, good. So thank you, Dr. Kandasamy, for small introduction. And today I am very much thankful to the organizer first. And today we are going to discuss about the first topic on disaster management strategies in agricultural sector and different planning and adaptation of alternate cropping system to mitigate out some of the disasters so far as the management part of the disaster is concerned. So far as the schedule of my presentation is concerned, I have put it in a very structured form, starting from introduction, the various type of disaster that are happening in the agricultural sector. We will have some discussion about what is disaster, because this is a very first class, so people may like to know about the disaster in general and various type of disaster that happen in the agricultural sector in particular. Different types of disaster, as we have already known, there are various type of disaster that's happening after 1994 onwards. So what are the different types, classification of the disaster, though it's not a mandate, but I have given only a small slide so that it will be useful for the audience. And what are the different management strategies to cope with the different type of agricultural related disaster, and what are the various adaptations methods also, that also we are going to discuss. And we are going to discuss about the cropping system, because cropping system is also one of the part and parcel of this the management strategy. So we are going to discuss about the cropping system, and we'll come out with some of the concluding remarks how we can able to cope with the disaster management part. So coming to the introduction part, as as I have just started this one, the very disaster, the terminology disaster has been come up with a French word. The terminology of the disaster has been come up with a French word. The name of the French word is disaster. If you dissect this disaster, that means comes in two different parts. That means des, and second one is aster. So des means bad and aster means star. So if you combine these two, this is known as your bad star, and or is known as the evil star. Just so disaster can be can be, that means from the French word we can able to have one meaning. That means it is nothing but it's broadly can be given a terminology as something bad that is happening to us. And if you want to define this terminology of disaster, uh, that can be defined in a very simple way. That means it's a disruption that happening. There's a serious disruption that happening, and when this disruption happens, it affects the functioning of the community or the society, and that causes widespread material, economic, and social and environmental losses in the system. And due to these activities, the community or the group of people, they lack the ability to cope with the situations, and obviously they need external relief or external help so that the situation can be coped up. So coming to Indian scenario, if you look at the Indian scenario, around 70% of our cultivable area comes under drought front. Drought is another type of agricultural disaster, and very details we are going to discuss about that. Around 59% of our land that comes under seismic or your earthquake type of hazard. 5% of our land is prone to flood-like situation. I'm talking about the agricultural land. And 8% of our land comes under your cyclonic type of events. So these all are different type of disasters, and it happens in our system. That means in our in so far as Indian part, Indian content in particular, and Southeast Asian country in general. Now coming to different type of agricultural sectors that disaster that happen in agricultural sectors, I have given into classified into 4 or 5 category. It can be more than that also. The first and the foremost part is different anomaly in the precipitational behavior. because most of our agricultural operations are monsoon dependent. If you look at the monsoon pattern and the behavior of the monsoon, you will find in the 21st century, the quality, that means the quantity and also the variation of monsoonic type of precipitations that happens. It happens not only due to your, with respect to space, also with respect to time, also this type of incidents, that means this type of things are happening. And as a result of extreme events of these precipitations, we are going to have serious consequences like a disaster, just like flood and drought type of events. We'll discuss about, because this, when you are coming about agricultural sector, drought and flood are very common occurrence. And third one is your tsunami type of incidents. Tsunami type of incidents is very common in our coastal regions, and we have around 7,500 kilometers of our coastal belt. That means if you look at including the continental coastal zone and also inland coastal zone, it comes more about 7,500 kilometers. And also hot and cold wave. Hot and cold wave is also one of the major you can say disastrous type of things that happen in our agricultural sector. Now coming to aberrant in the precipitation of behavior, if you look at the changing climate scenario, precipitation and the temperature is also changing day by day. That is also, that means almost all of us are experiencing this type of phenomenon. And as a result of that, there are various type of catastrophic consequences. And in most of the metropolitan cities, you will be agree with me, if there is a shower of rainfall for around half an hour and so, we are going to have a splash flood like situation in most of our metropolitan cities. And these are due to various, that means anomaly in our precipitational pattern. And drought and flood are extreme events of such type of outcomes of this one. Apart from that, hailstorm, snowfalls are also happens, and that causes unseasonal agricultural losses. Coming to drought, drought is the consequences of natural reductions in the amount of precipitations over an extended period of time. And some of the researchers, they are working with the drought-like scenario, drought type of phenomenon. They have defined it. It's the most complex and least understood type of phenomenon. Very crisply, very small and very crisp type of definitions they have given. Very most complex and very least understood type of phenomenon. Generally, when a particular region receives a constantly below the average amount of precipitations, in that context, we are telling that this the region comes under a drought-like situation, and it has substantial impact so far as the ecosystem of the particular region is concerned, and also the agricultural sector in general. And as a result of that, due to drought-like situation, there is a large-scale migration of people and in search of their livelihood and in search of their day-to-day activities. And if you look at the picture of the probability of drought occurrence in India, you will find almost all parts of our India comes under your drought-like situation. If you look at the western part, the probability level is in the tune of more than 40 to 50%. That means your Gujarat and your western part of Rajasthan. And if you look at the north part, that means your northeastern extreme part, the probability is very less, in the tune of 0 to 10%. Apart from that, most of the peninsular regions comes under a probability zone of around 30 to 40%. This is the drought probability occurrence in our Indian state. Now coming to different type of drought, so we will discuss about the contingent measure. Apart from having a discussion about the different type of drought, it starts with the very first drought, that is known as geometeorological drought, and it precedes all kinds of drought when a region receives a rainfall, average annual rainfall, which is less than 70% of a long-term average. When you're talking about the average rainfall, generally we are taking more than 3 decades of rainfall. That is average mean value of arithmetic mean of more than 30 years of rainfall. That value we are talking about the normal average rainfall. When in a particular period of time, with this amount of rainfall is less than 70%, we are telling that this region comes under your meteorological drought, and this is the very first signal that happens so far the drought type of incident is concerned. Apart from this classification of meteorological drought, then it comes to the agricultural drought. Agricultural drought is when there is insufficient of soil moisture to meet the particular crop requirement. Under the circumstances, we are telling that the region comes under the agricultural type of drought. It affects agricultural production, ecology, and also the ecosystem of a particular region. It arises from different types, again, the change in the precipitation level. And it's a traditional type of drought, agricultural drought, and it extends a quite a good amount of period also. And apart from your agricultural drought, there is another type of drought, is known as your hydrological drought. And when there is a deficiency of surface and a subsurface type of water supply, a drought-like scenario exists. This is known as your hydrological drought. It is measured at the stream flow and also the lakes and reservoirs, and also the groundwater level also diminishes. As you can, that means the soil water also deplete more rapidly, and this that means this extent for a good amount of period. So these are three different classification of your drought-like scenario. Then before managing this type of drought-like scenario, we need to know, that means how we can able to quantify this type of drought. And for that, there are various type of indices has been given. Those students, they are working with this type of extreme events. They would like to find out this type of indices. One is known as PDSI, that is known as pulmonary drought severity index. Aridity index, that short form is AISMDI, and standard precipitation index, that's a abbreviation is SPI. And for that, there are various type of inputs requirement is equal. That means what are the data they require. Mostly they require potential evapotranspiration data. They require daily, daily or weekly or monthly rainfall data for a good period of time. Around 20 to 30 years of data are required for finding out different type of drought indices. Apart from this type of drought indices, we have different type of other type of indices also. These are known as R indices, Z indices, WRSI, that is water requirement satisfaction indices. These are some of the quantification of to find out how we can able to do with the drought type of incident. Now the latest one is NDVI, normalized difference vegetation index. Those people, they are working with your remote sensing and GIS type of high-end tools. With your remote sensing satellite images, we can able to find out how we can able to that means your NDVI values also. The range of this NDVI generally starts from -1 to +1, and accordingly, if you find out this one, quantify this NDVI value, we can able to have some of the strategical approaches to to manage this type of drought. Now coming to different type of impacts that happens due to drought, it has been classified into three different part: environmental impact, social impact, and also the economical impact. Under environmental impact, it is comes that means moisture stress is being realized. There is a losses of drinking water, degradation of the resources, and increase of pollutions. So far as air and water, these natural resources pollutions are concerned. On the environmental part, drought leads to this type of disastrous type of incident. Coming to your social impact, malnutrition, ill health, and mass migration from one place to another. Coming to economic impact, there is a fall of agricultural production, reduce of income, losses of livestock, fallout, and there are various type of bad consequences of this drought-like situation. Then how to manage this type of incident? If you look at the management strategies, some of the research group, they have found out there are some of the decision support system to meet out or to mitigate out this type of drought and different type of agricultural related disaster. This is one of this type of the front end of this drought management software. Is a decision support system. It has been, it has been given by the PRIDA, Hyderabad. They have come out with a small software. By using this one, we can able to have some of the strategical intervention, so that we can able to have some of the plans. If there is a drought like situation, what has to be, what are the different contingent measures. Coming to the short-term measures and also the long-term measures, so far the drought-like situations are arising. Coming to short-term or immediate measure, that means we need to have some labor-oriented schemes, so that it mitigate out the mass migration of people from one place to another. We need to go for some good weather coding type of system, so that it also in short term we can able to we can able to have one of the contingent measure. Then establishment of some of the banks, that means your fodder, seed banks, grain banks, establishment of some of the cattle camps are also there. These are all comes under your short-term measures so far as your drought-like situation is concerned. Coming to long-term measures actually require a lot good set of observation data and also lots of research R&D activities, and it has to be given around 2 to 4 months in advances. The long-term strategical intervention, regional analysis of rainfall pattern, integrated water management, land use and land cover diversification, water harvesting, especially your rainwater harvesting, and also the in situ moisture conservation strategies. This comes under your resource conservation uh, strategies. These are can be taken up in a long-term measure to address to mitigate out your drought-like scenario. Now, coming to mitigate, there are certain things in a drought like in disaster paradigm we need to understand. There is certain things we need to have a strategy for adaptation, because some of the most of the natural disaster we cannot able to mitigate out. So we need to be with the system. For that we need to develop our adaptation strategies. Some of the natural disaster with advanced research and R&D activities and all, we can have we can have some resilience methods also, so that we can able to resilience strategies. And some of the disaster we have some mitigate plan also. If this type of scenario arises, we can have some plans so that we can able to mitigate out. Cloud seeding is one of the option. So far as the drought part is concerned, we can able to have a measure of cloud. That means we can able to have some mitigate out planning. Those The cloud seeding activities in Indian part, it has started in early 1980s in Pradesh and Telangana region. But so far as it's technically feasible, so far as economical point of view, actually it is not that much. It has not that much. It has not come off in that way. So cloud seeding, but these are some of the things that can be taken off if we want to mitigate some of the disaster like scenario. Second one is your desalination part. That means taking out fresh water from the sea water. Though it is a proven technology, and but again, so far as the cost part is concerned, people are still trying to find out some of this filament. That means your filter filament, so that this cost part can be minimized. That means it can be made available to the common people. But in the southern part of India, in Madhya Pradesh, Karnataka, your peninsular part of your Kerala and Tamil Nadu, you will find in some pockets these desalination methods for for taking fresh water from seawater. Some of the big industries are working on that. Now coming to drought monitoring part, also this is also one of the mitigation strategies can be taken off. And what are the other mitigation strategy? One is known as the LULC part, that means land use and land cover. Careful planning of the rotation of the plant can also help to minimize the erosion and also allow the farmers to plant less water dependent crop. This is also one of the strategical intervention can be taken out, so that agricultural disaster part can be addressed nicely. And very well spoken terminology, I hope almost all of you agree, is your rainwater harvesting. Now also government of India has given lots of strict rules and regulation. Even if you are going to have some of the building in cities and all, you need to have a water harvesting strategies for domestic sector and also for commercial complexes and all. But to my surprise when I have just going through some of the literature, only 6 or 8 states out of 28 states of India, only 6 or 8 states, they are in principle, in pen and practice. That means in principle they are adhering to this type of rules and regulation. Other states they are not. So we need to have one brainstorming activities. That means what went wrong. If there is the rules and regulations are there, why we are not adhering to this type of situation. That means this type of practices. Now coming to another practices is known as your recycling of the water. That means from wastewater, from the sewage, having a sewage water and all, we can able to go for so recycling of the water so far as agricultural uses can be enhanced. And beautiful research work has been done all over the world. That means how we can able to recycle water from the sludge water. In Kolkata, there is a model also, that means from municipal sludge water, how water can be reused after giving a small treatment. This water can be made use for agricultural purposes. And also aquacultural wastewater, that means you will find in Andhra Pradesh and some part of Tamil Nadu, and also in Gujarat and your Maharashtra and all. There are good entrepreneurs. They are doing aquacultural practices in a commercial way. And as all of you may knowing that aquaculture is not a consumer of water, but aquacultural living being. They require water for their growth and development. So what happens when you go for intensive type of aquacultural practices? So the culture water get polluted. So this water can be made use. That means we need to for rearing of these aquatic animals, we need to extend this water. And this type of very phenomenon, I hope almost those people they are having a small aquarium at home, they maybe have this type of experience. Similar things also happen in industries also. And this extends water is a nutrient rich water. So instead of throwing it to the big aquatic system, if we can able to use this one as a irrigation water, so lots of things can be brought under control. Now building of canals, redirecting of the river, and also many massive structure, creating massive structure also one of the way, so that the drought prone areas can be brought under control. And unnecessary use of outdoor water uses, that means regulating the use of sprinkler, hose pipes, buckets, and also that by that way also we can able to address these issues to a greater extent. Now another is your risk transfer, transferring of the risks from one place to another. This is nothing but known as your insurance people are also coming up in a bigger way. You may be knowing that the government of India has also giving, that means your crop bima yojana, that means your it has started in early 2006, and and also most part of our, that means most of our agricultural productive states, they are adhering to this type of schemes, that means agricultural insurance scheme. I want to again repeat the same thing, that no state is immune to natural calamities. Almost all the 28 states they have this type of that means disaster from small to a greater extent. Okay, so to have one risk transfer from one sector to another, we can have this insurance of crop insurance, so that if there is a problem, certain times a premium value that insurance sector can able to give us back. Now coming to another disaster that happens in agricultural sector, and it's also happening in a very rampant way. It's known as flood. Drought part is something that we have discussed a little bit earlier. Now coming to flood part. If you want to define a flood, it is nothing but an overflow of water. Overflow of water, mostly from river and bank and on most of the uh, reservoir or big water bodies. And major cause is only the surface runoff. If you want to correlate between the rainfall and your runoff, you will find there is a direct relationship between the rainfall and runoff. And there are various type of researcher, they have also give their that is what type of by using lots of models activities, how if there is this much amount of rainfall, how much amount of runoff is going to be happen. And if you look at the eventualities, that is the extreme eventualities, just like a flood type of situation, that depends on, that is the surface runoff, how much quantum of extra amount of water that has been come up after your rainfall type of incident. It depends on two characteristics broadly. One is known as your watershed characteristics. Second one is your precipitation or your rainfall characteristics. As in the watershed context, I am discussing this part because almost all the agricultural fellows they may be knowing what a watershed is. It is nothing. It is the region watershed. That means it's a region having a single outlet, and mostly if you want to define it in a technical way, it's nothing but a geohydrological unit having a single outlet is having given the name of a watershed. And we need to understand the various characteristics of the watershed, and also the characteristics of the rainfall pattern that happens, that falls over this watershed. Then only you can able to have and understanding and a clear picture of the flood type of incident. And also based on the origin and based on the characteristics of that means flood, it has been classified into different type, because we are not going to discuss about the classification of the flood. Just for the understanding, around 8 type of classification of the flood can also, that means people have worked on, and they have classified the flood into 8 different type or 8 different categories. Now, looking at the damages that happens to the flood-like incident, that means mostly the damage happens due to a cultivated land, erosion of the top soil, which is mostly the nutrient-rich type of soil. It happens to the agricultural sector. Then collapses of the household, losses of human life, and also there are various type of catastrophic diseases that also happens due to your flood type of incident. Now coming to different type of flood forecasting methods, because do have little bit of idea, those nowadays also, except natural disaster, that is your earthquake, almost all type of disaster, natural disaster, we can able to have a forewarning or forecasting method. Let it be your drought, let it be your flood, let it be a cyclonic type of incident, let it be tsunami and all. We have classic S&D, that means your science and technology type of R&D wings, so that it can easily able to find out well in advance, and that not only save the life, that also save that means your belongings, and also lots of that is movable and immovable type of structures. Now coming to the classification of the flood forecasting methods, it comes under your 3 different type of forecasting methods, starting with your short range forecasting that happens only 12 to 14 hours before, mostly that helps in the metropolitan cities and all. It takes into consideration the precipitation of a particular region, and also AMC condition, and this antecedent moisture condition of the particular region, and also the variation of the stages of the upstream side of the river bank. Coming to the second, that means second type of forecasting, that is known as your medium range forecasting, that happens between 2 to 5 days well in before. And for that, again, we need to study your rainfall and your runoff characteristics, and also there are various type of scientific what things has been comes into picture, so that we can go for a medium type of forecasting method, that is a forecasting. For long-range forecasting, generally it's require radar and your meteorological satellite data, so that we can have a long-range forecasting from, more than 1 month before. Also, forecasting things can also be possible. Now coming to Indian flood control system, if you look at the flood control mechanism, or it's known as your Rashtriya Bard Ayog, there is an institute who is working on exclusively on the flood type of incident. Mostly our Himalayan belt, that means your perennial rivers, they are account for around 60% of the flood damage, and mostly this happens during the month of June to September. And around 40 million hectares of land, agricultural land I'm talking about, is liable to flooding of different intensity. And this type of incident happens mostly in 4 or 5 different states in India. Your Uttar Pradesh, Bihar, West Bengal, Assam, and Odisha. These 5 states are mostly frequently, that means every 1 and 2 years alternatively, they are experiencing this type of flood type of incident. And so far as the Indian flood control part is concerned, we have around 12,500 kilometer length of levee. These are known as your structural measure for flood control. I'll discuss about that. What is the structural measure of the flood control, and also the non-structural approaches. To get rid of this flood type of incident, we have 12,500 kilometer of the levee. Levees are known as your earthen embankment, and also we have 25,600 kilometers length of a drainage channel. These are also useful quite a good extent to nullify the flood type of intensity. These data you will find in the public domain. Whatever the data that I have taken from this IMD, CWC, Central Water Commission, Government of Ministry of Water Resources. And we have forecasting has been done well in collaboration with the CWC, Central Water Commission, in close collaboration with the IMD. There are 9 number of flood metro offices, and CWC has 141 number of flood forecasting stations, and it provides that coming to flood forecasting stations in India. We have 5 different flood forecasting stations. One is in New Delhi, who is to look after the Himachal Pradesh, Punjab, Uttar Pradesh, Haryana, Jammu Kashmir, Rajasthan, and Delhi. Kolkata flood forecasting stations used to look after the states of Bihar, Assam, West Bengal, and Odisha, and also some part of your northeastern part also. Chennai used to look after the southern part, that is Tamil Nadu, Andhra Pradesh, Karnataka, and Kerala. Mumbai used to look after the Gujarat part and the Maharashtra part, and Nagpur. We have 2 stations in the state of Maharashtra, Mumbai and Nagpur. Nagpur used to look after the Madhya Pradesh and the Vidarbha region. These are the flood forecasting stations operated by IMD, and it is in operation. They are also giving a good amount of the forewarning and forecasting system so far as this flood type of incidents are concerned. Now, if you want to have a control mechanism of the flood, we need to understand the very 2 basic principles. That means we need to modify the flood, or we need to modify the susceptibility of the flood damages. Okay, so these 2 things are in a broader way, it can be classified. That means if you want to control this flood type of incident, we need to go for these two to approach whatever the methodology it may be. Now coming to measures to overcome the flood, I have told you a little bit earlier that we need to have 2 different type of measures. One is your structural measure, and another is known as your non-structural measure. In structural measure, generally we need to go for constructing different type of structural approaches. Some structures, mechanical structure has to be constructed, and obviously this is a cost. It is not a cost economic point of view. It requires a good amount of money so that the structure can be made in operational. So what are the structural measures? So these are known as levees, that means your flood embankment, storage and detention type of reservoirs we need to create. We need to go for improving the channel improvement. We need to go for some flood bypass ways, that we'll discuss about what are the flood bypasses are there in our India and how it is useful so far as the overcoming this flood type of incident. Then we need to go for some of the soil conservation measure in the watershed scales. These are all structural measures has to be taken in letter and spirit so that we can able to overcome this flood type of incident. The second one is your non-structural measure, because it doesn't require any structure to be implemented, which to be made in position. We need to go for flood plain zoning. These all are your social or community based approach. We need to in a particular region which is receiving a good amount of flood and all, so we need to make a zonation in that region so that the evacuation, relocation, and the warning part, that means all these things we can able to reorient the people affected in the affected area to a safe zone, so that losses of life and also on different type of, that means your movable properties can be curtailed to a great extent. Now coming to different type of flood protection measure, once I have told, I just discuss about the levee. Levees are nothing but your earthen dike type of environment. You can see this is a flowing river, and the both sides you will find there are levee your earthen dike type of structures are there. And mostly these earthen dikes are made in practices if there is a you can say households are nearby, near to any flowing river bodies and all. If there is a settlement or people used to stay nearby your big river and system and all, so to get rid of this type of incident, we need to make a small earthen structure or dike structure. These are known as levee. Those these are not that much effective, but it is economical to control flood of small intensity. Mostly in Indian subcontinent, we have good amount of levees are also there, so they are also able to help us that means to not affecting this type of that means surge in the riverine system. We need to go for some of the flood wall also. These are known as retaining wall. Mostly, again, it's not that much cost effective. You require a good amount of money. These are mostly constructed with RCC, reinforcement concrete, and also masonry structures. These are also helpful in controlling the flood damages. We need to go for different type of storage reservoir. These are reliable and also effective method of controlling the flood. They stored water mostly released in the control, and also they used to control. That means when you want to control the water, it can be controlled. It can be stained in a controlled way. So we need to make, again, these are also not that much cost effective. Hirakud Dam and DBC projects are also some of the examples so that storage reservoir can be made feasible. Detention type of reservoir also these are small structure as compared to your earlier one, the storage structure. These are also helpful in reducing the peak flood losses. And another one is we are making a bypass system so the flood ways so that the intensity of the flood can be neutralized. And we have this flood bypass in the state of Jammu and also in the state of Andhra Pradesh in the river Jhelum river, so that the water can be bypassed to the lake Uller Lake. And also in the Krishna river also in Andhra Pradesh we have this flood bypass mechanism so that the intensity of the flood can be minimized to a greater extent. As I've told you that we need to go for some of the watershed based activities. So far as the soil conservation part is concerned, we need to make some incidents so that the increase of infiltration can be increased. That means the infiltration part can be increases. We need to go. That means the evapotranspiration part can also be increased. Small and medial flood type. That means if you want to go for this type of measure, we can able to overcome very small or medium type of flood like incident. Strengthening and your deepening of the riverboard bed is also one of the measures that also helpful in overcoming your flood type of incident. Another one is your floodplain management. These are a non-structural measure, and for that we need to go for different zonation in the affected area: warning zone, restricted zone, and prohibited zone. And these are non-structural measure and mostly helpful in the community level so that the losses of life can be minimized. Another type of incident is known as your tsunami type of incident, as we are going to discuss about the agricultural part in general and also disaster part in particular. So I think we need to give a little bit emphasis on the tsunami also. Tsunami is again a extreme type of natural disaster, and the name has been coming of from a Japanese word. It's known as your tidal wave or known as your harbor wave. It affects the distant shore originate from the rapid movement or rapid displacement of the water that may be due to your seismic activities, due to earthquake type of incident, due to landslide type of incident, and also due to your falling of large meteorite in the aquatic environment. And here one point I want to raise here, just trying to put before all of you, when we are anticipating one type of incident, just like there is a chain type of incident, one leads to another one. Similarly, a tsunami is also one type of end product, you can say. If there is a seismic incident and also the volcanic type of incident, we are going to anticipate this type of tsunami type of incident also. So those that means sea water used to come out to the that means to the shore with a very high intensity and with a high velocity, and losses of life are also happening. And not only the losses of life, losses of agricultural land also, adjacent land, because most of the coastal belt land are fertile land. When tsunami type of incident happens, it gives a disastrous consequences to the agricultural field also. So coming to the possible risk reduction, so far that in a tsunami type of incident as concerned, we need to make some of the walls. These are known as tsunami walls. Tsunami walls are mostly being raised up to a height of 4 to 5 meter. But there are some incidents where the tsunami waves used to come up to a height of more than 100 feet. So sometimes it is not what um, it cannot able to handle this type of big tsunami waves when it's coming up in a huge way. But small tsunami waves, Japan and all, and in the coastal region, they have a common with some of the tsunami walls. Another type of incident, so far as the agricultural part is concerned, is known as cold wave and also heat wave. I hope almost all of you are familiar with the heat waves that coming up in the 21st century in almost is the experience of almost all of we have experienced this type of incident. It is a prolonged period of excessive hot weather and accompanied with high humidity and all. So these are known as your heat wave. And according to World Meteorological Organization, they have defined the heat wave. That means when a particular region consecutively for 5 days experience a temperature which is more than 5 degree of the ambient normal temperature for a particular region. So under their circumstances, this region will fall under your heat wave type of scenario. And heat wave and also cold wave, these are also your that means your atmospheric abnormalities that comes in a longer way in the 21st century. Now coming to what are the side effects of so far as the heat wave is concerned, mostly it affects to the that means your older people and also younger people and overweight people. Hypothermia is known as heat stroke. Most of the in 1999 there is a heat wave type of incident that happens in the coastal part of eastern India where losses of life, human life, are in the tune of more than 200 in number during the month of May and so. So not only there is a losses of life due to this type of heat wave type of incident, there is a losses of happens in our agricultural sector. If you look at the physiology of the crop, we have three different type of crop. One is known as broadly we can be classified into three different way. One is C3 type, C4 type, and third one is comes under your CAM type because of the photosynthesis mechanism or physiological mechanism that happens inside the crop. Now coming to C3 and C4 type of crop, some crop are if there is an increase of temperature, that some of the researchers they have told under C4 type of crop, if there is a temperature enhancement of 3 to 4 degree, there is a positive sign of the yield. But opposite the cases, that means when there is a increase of temperature, C3 plants they yield less. That means the yield reduction is being happening to a tune of around 30 to 40%. And according to IPCC protocols, that means we in the 21st century we are going to experience the temperature of around 2 to 2.4 degrees centigrade of the normal ambient temperature. And you can understand the various consequences, bad consequences out of the increase of the temperature also. Not only it happens to the agricultural field, it happens to the human. That means there is a threatening to the life and also some of the your oceania small islands, they won't be there in the time to come after 20 to 30 years. These are some of the bad impacts of your heat wave. Now coming to cold wave, that is the opposite sides of your a heat wave. Cold wave is a weather phenomenon that distinguished by your cooling of the air. There is a rapid fall of the temperature of during the 24 hours, and that affects not only to the human being, that also affect to the agricultural industry, commerce, and also the social activities. Again, coming to the side effect, ill side effect of your cold wave, that's losses of life, injury to the livestock, and also wildlife. Also, the pipelines and all the water supply lines are also being choked. So there are other type of unforeseen type of problems that happens due to your cold type of incident. So these are whatever we have discussed earlier, starting from drought, flood, tsunami incidents, and also heat wave. heat wave and cold wave, what are these type of incident and what are the contingent measure that we need to follow. After cropping system, alternative type of planning of different cropping systems so far as agricultural part is concerned. Here, two, three terminology I think I need to put. So for the audience will can able to have one understanding. We need to have idea about what is a cropping system, what is a cropping sequence, and also what is a cropping pattern. Cropping systems that refers to the type and the sequence of crop generally grown, and also the practices for practices then generally we are growing in a particular region. And so far as Indian part is concerned, mostly we have rice-based cropping system. We have rice-based cropping system, and in the northern part we have rice after rice wheat based cropping system. Some patches we have maize based cropping system and also some of the corn based. That's a box and to go for the technology part and definitely crop technology and all different type of also the based approach so that we can what offers to other. When a particular crop is reported it's a crop pattern of that region. Okay, so for us to go for some of the strategical intervention in the cropping system. There are lots of local land races are also there. Let it be rice, let it be maize, let it be wheat and all. So they have a good tolerating power so far as your biotic and abiotic type of stresses are concerned. So these are things that have to be that means into confidence. So far the has to be that means it has to talk to about this rice-based cropping system that exists by wheat-based type cropping system. Rice-wheat-based cropping system is mostly prevalent, and vegetable-based cropping system is very rare. So far as the commercial type of cultivations and variable crop soil weather and also the different type of varieties, and also it's a high input type of cultivation practices so far as the commercial cultivation parts are concerned. So coming to adaptation strategy, what has to be done? Make it a proper decline during swing of rainfall. Yes, please. Where there is a dry spell of so according to the recreational sources, contingent crop planning, and also alternate type of cropping system. It's not. Hello, am I audible? Am I audible? Hello.
Your voice breaks in between. Hello, sir. I think. Sir. Hello. I think sir has some network issue. Let us wait for some few minutes.
Dr. Lala? Yes. He has some network problem, I think. He has some network and he will join again.
Sir, he is here. We can make him co-host again.
Madam, madam, he has some network problem, madam, and he will join again.
Yeah, I think he joined again.
Yes, yes.
Hello. Hello.
Yes, Lala.
Yeah.
Hello. Yes.
I'm
Yes.
audible. Yes, Dr. Kansam.
Yes.
Can you hear me? Okay. I
Yes.
am almost done with my presentation. If you can be given 10-15 minutes time, so we can have a small discussion.
Okay.
Okay.
Dear participants, Dr. Lala, he has presented very nicely and he has covered so many aspects. Almost in the given topic, he has covered entire things, and due to his network problem, he could not join. And if any doubt, participant can ask directly and kindly unmute, then ask your question. And if any question, you can drop in the chat box also. Any questions from participant side? Please ask.
Sir, what we can do is, can we have a question and answer session in the end?
Okay, madam. Okay. Okay,
So,
that can be done.
Till then, our next speaker can speak, and meanwhile, if people have any questions, they can post it in the chat box. Kandaswamy sir, can we move ahead?
So I am inviting next speaker, Dr. L. Kanta Singh. Just a small introduction about Dr. L. Kanta Singh. Dr. L. Kanta Singh did his PhD from Agriculture and Food Engineering Department in IIT Kharagpur. Currently, he is working as a subject matter specialist in soil and water conservation engineering in ICR KK Imphal West and ICR Research Complex for Digital region, Manipur Center. Today, Singh has more than 40 published in national and international journals, and also obtained various awards from different organizations. So, this brief introduction, I am inviting Dr. L. Kanta Singh to deliver lecture. He is going to deliver a lecture on soil and water management in disaster affected areas. Yes, sir, you can start your speak.
Kanta Singh sir, you are here? Sir? Kanta Singh sir? Kandaswamy sir, can you please confirm what is the problem?
Yes, madam. I will talk to him.
He is having some connection issue. He'll be joining shortly. Just give him 2 minutes.
Okay, okay.
Audible? Hello.
Yes, sir. We can hear you.
Soil and water. See, I
So we can't hear you still.
consider Tsunami. So come consider sector. here's what's here. See, here, here, South Asia, Sri Lanka, China, maximum. See the water tension to see it's an five like it's from see it's 6 this is the front. See, mostly sound. Also, prone that should be a faster street. While physical three sees
Really sorry to interrupt you, sir, but we cannot hear you at all.
close to the top, proving public so so water serving lie of down Hello. Hello. Am I audible? Hello.
Yes, sir. Yes, sir. Now you're
Hello.
audible.
Yes. Okay, I will.
Sir, we really sorry, but we could not
Shall I
hear
start
you.
or
Yes, sir. That will be good.
shall I start from? Okay, thank you.
Thank you, sir.
Respected Chairman, distinguished members here, delegates, I would like to present my topic on soil and water management in drought flood affected areas. As you know, the volume of water is a major component is the ocean water that is of 97.5%, or of very less amount that is of 2.5%, that is about 35 million cubic kilometer, out of which we can find glacier and the ice cap, it is of 68%, followed by groundwater, that is the 29%, and direct accessible water, that is the form of surface water, that is of 3%. As you know, over the world, the high income countries and compare with the low and middle countries. If you see in the low income countries where the water use in the agriculture sector is very high, that is of 82%. In case of the high income countries, the agriculture use of 30%. So as you know, agriculture consumes the highest amount of water. And in case of the low and middle income countries, the amount of water used is 82% in the agriculture sector. So this is the major amount of water consumption where it is happening. And if you see the water budget of India, the total volume of water annually, according to the annual precipitation receipt, that is 120 centimeter depth of rainfall average. And if we multiply with the geographical area, and we get the 4,000 cubic kilometer of volume of water, out of which surface water that is of 690 cubic kilometer, and replenishable groundwater that is can be utilized safely, that is of 432 cubic kilometer. And again, I would like to show here is the South Asia. If you see that this graph, South Asia and Central Asia, if you see these particular developed countries where the sharing of the water is almost equal, and in case of this South Asia, like countries like India, Pakistan, China, where the agriculture consumes more than 91.2% of total water, and in case of industry, it is 6.9. So if we can concentrate this particular water use efficiency, sector of agriculture, we can save lots of water, which can also fight for this flood as well as drought mitigation. Similarly, according to the Central Water Commission 2000, and there is a likely that there is a trend for increasing water demand, and the highest demand is in the field of irrigation. That is present demand is of 541 billion cubic meter, followed by the 2025, that will be around 910 billion cubic meter, and by it is likely to be increased by 1,072 year 2050. It is based on the food production and amount of irrigation water requirement based on happens because of the population growth of our country. And the damage from the flood, if we see here, area affected and on an average, that is 7.63 million hectare, that's the average. And crop area affected is 3.56 million hectare. Population affected is 32.92 million. And total amount that damage on an average is US dollar of 307 million. And you see here in this map, in the red color is showing the flood prone, mostly Gangetic plain areas, Putra Valley of Assam, and also West Bengal, parts of the Odisha as well as Andhra Pradesh. According to the National Water Policy as regards the flood control and moderation, there should be a master plan for flood control and management for each broad basin, and adequate flood should be provided in water storage projects wherever feasible to facilitate better flood management. In highly flood-prone areas, flood control should be given overriding consideration in reservoir regulation policy, even at the cost of sacrificing some irrigation or power benefit. While physical flood protection works like the embankment, dikes will continue to be necessary, increase emphasis should be laid on the non-structural measures such as the flood forecasting and warning, floodplain zoning, losses, and reduce recurring expenditure on flood relief. Approach to the drought management, improving national capabilities, including training human resource development for assessing water resource and determining water use on a continuing basis, and for the planning and management of these resources, conserving water resources and optimizing their use, augmenting the supply of water locally by exploiting surface and groundwater, taking into account long-term trend, the future demand of the local communities and other needs, augmenting the supply of water by transfers from more permanent surface water resources like lake and rivers, and from groundwater resources in arid and semi-arid areas, and long distance transfer from humid areas if practical and economically possible and environmentally acceptable. And I would like to show here, as per this norm and the flood control that 1002, that the soil and water conservation, just some of the structure I would like to share here, which helps in particularly hilly as well as the valley foothills areas. As we know, control bunding is a very good structure, which can even, because it can be used very effectively in the hilly region. It is also conserving the top layer, so which is very fertile soil, and it is also helping to convert slow conversion of terrace. This is one of the very successfully in the northeastern areas of India. And also terrace, as you know, terrace is in the Barapani, this particular terrace has been used for the more than last 35 years, and their productivity is quite sustainable because the production has not been decreased. Using such kind of in the slope area is not only the harvest the water, also control, it infiltrates water into the soil. So this is also another structure I would like to see here. And this is a plantation, because the fruits like oranges and many other important crops in the northeastern region and other parts of the country, because like half moon terrace, it only protects it, because we don't need to disturb all the soils, only at the each plantation area, only of diameter of 1 meter to 1.5 meter, constructing half moon terrace that can be only operate this particular area. Then rest we can keep with the vegetation cover. That way we can also conserve the soil that can mitigate to fight against the flood as well as drought conditions. Similarly, this kind of trenches or staggered trenches will also help to harvest the water, as well as it can also control some of the flood, like flash flood, the slope area, which can infiltrate water. And some of the structure like, because in the hilly region, the gully plugging is very important, because this particular will filtrate the soil particle. It will stop the soil to move. At the same time, it will also slow down the flow of water and will help to infiltrate. It will help to for groundwater recharge, as well as it will also filter out clear water, will be allowed to move away. Similarly, such kind of rainwater harvesting pond, which plastic lines are very low cost, which can harvest good amount of water, and it can also help in case of the drought-like condition, give the life-saving irrigation. And like in some of the mountainous region, this is the dew harvester. It's very useful because there are very less rainfall. This can even harvest good amount of water for our people to survive. This high altitude area where very less rainfall occurs, because of such technology can harvest some amount of water, which can fight the drought-like situation. And such kind of checkdams are very useful in the northeastern region, where it will not only harvest the water, as well as it will also slow down the flow of water, so that such kind of occurrence of flood will be prevented. At the same time, this water can also be useful in mitigate the drought-like situation. So I would like to share, because already the norms has been given that some of the, because to fight against the drought, we need to know that there is also dynamic groundwater resources. At the same time, groundwater potential zoning is very important, because if we know particular this area where the sustainable groundwater is available, then this will be useful to fight our drought-like situation in many of the countries. So I would like to share one case study which I have taken up in the Damodar Canal Command of Eastern India, that is in the south central part of the West Bengal, where I have used two models, that is the HP and the catastrophe techniques. That is all multi-criteria MCDA technique. So approach one I have taken, all are based on the remote sensing and GIS platform. And this has been taken up because the cost is very less. At the same time, the financial involvement is very less. And it can also do very large area, and it can give very good results, so that it can also help many of our farmers and other planners, managers to use such knowledge, fight against the drought-like situations. These are the flowchart delineating the groundwater potential in HP and catastrophe techniques. And some of the layers I have used, this is the land use, land cover, and this is the soil texture, this is the runoff coefficient, and this is actually one new technique I have developed. This is runoff coefficient is a derived layer, which we have also used the soil, rainfall, and other curve number. All this has been put and formed to this curve runoff coefficient. This a derived layer. Then I have also used drainage density, which I have used using the SRTM DEM, the digital elevation model. Using this, I have also delineated the drainage density. And this is the geology map, which I have collected from the Geology Society of India. And this is the slope map in the GIS, SRTM DEM. That is the resolution I have used. And this is the proximity to surface water bodies using the land use lab, which I have received from the remote sensing agency. So using the weighted aggregation by weighted layer combination method, and using these in the GIS platform, all the layers, all the 5 layers has been delineated by providing different values. Using the first approach, that the HP and hierarchy process, and out of which some good area is a maximum of 49%, and very good is 15%, and moderate is 20%. Using this map, we can also have some more feasible groundwater, like pump and all, can utilize that excess that water, so that can be get for this drought-like condition this area. Similarly, using the approach to that is the catastrophe technique. Here also similar result has been found, and good is the 63%, followed by moderate and very good. And again, we have compared both these models, and both are giving maximum in case of good, followed by moderate, very good, and poor. But the percent, then we thought, why not we should validate that, so that which model is providing better results. So for that, I have used the dynamic groundwater reserve, which that has been at the point level has been used, and during the HP, that is giving 82% accuracy in case of catastrophe, that is 74% accuracy. So based on that, I have published the ecological indicator, one paper, the ecological indicator, that is having more than 4, and another paper that is again one approach we have, that is hybrid approach using both the technique. I have also, this is also almost near about 4 to 3.9 something back, Geocarto International. And again, rainwater harvesting is very important, because why? Because already we have shown that groundwater, there is a potential to use the groundwater. Then we need to recharge them. We need to recharge, and at the same time, we need to harvest the groundwater. That will also control the flood, as well as it will also enhance the groundwater potential. So for that, we also delineated which particular area will be suitable for groundwater delineation. And that way, again, MCDA technique has been used, that is HP has been used here. And a similar technique I have followed here. Already I have shown some of the layers are similar, which I have in this one, and this layer I have not shown. That's why I have, this is the hydrologic soil group, and again, this is runoff potential both way, but their assigned value will be different, because in groundwater it will be different, because the both will be assigned different way, because one is for the groundwater and one is for the rainfall potential zone. So similarly, stream order, because this is very important. Here, some structure will be constructed. So we have used the stream order up to, though there is a up to 4 stream order, but we have, second and third is very important because some of the structure has to be constructed in this particular, so that that structure will be effectively utilized by the farmer as well as in this area. And this is the area where we have found that groundwater potential zoning, and high potential zone is of 47%. Similarly, this kind of criteria we have followed. That is the farm pond where to be constructed. That is the based on the land slope. It should be less than 3%, and land use should be on agriculture, and soil should be fine texture, because the farm pond water has to be stay there, and it has to control the percolation as well as seepage losses. So the fine suitable soil should be texture. Similarly, percolation tank on the ground as well as on the stream. So on the stream, it should be less than 5%. Similarly, again for the check dam, we have to construct less than 15%. And the soil, we have to consider like fine texture. And drainage, as I have mentioned, second and third are very important. These two are the order where we have utilized for the effective construction of the water harvesting structures. And these are the area which have delineated for the check dam, percolation tank on the degraded forest, farm pond. The blue color are suitable for the farm pond. And again, the structure where we should locate, that has been, and for the check dam, green is showing the green, that is suitable for the check dam, and percolation red color, that is a percolation tank. So that way we have to identify the proper location. So accordingly, we have identified this particular area, study area, about 2,314 square kilometer area is suitable for the farm pond. And the percolation tank is of 42 square kilometer. Percolation tank along the stream is 69 numbers, and check dam is 33 numbers. And from this, I have also published one paper that is in the Journal of Cleaner Production, that is having impact more than 9. And another paper that is also environmental science and pollution research, that is also planning rainwater conservation measure using geospatial and multi-criteria decision making. And that is having more than 3 impact. And again, is also one consideration is that though we have the resources, but some particular year we found that that is a dry area. It's like a drought-like situation. So why not we should also optimize our resources so that we can enhance our production. So optimization technique was also applied using the existing resources as well as existing plus the dynamic groundwater resources, which are safe groundwater to be applied. So linear programming was used. These are the objective functions which I have formulated. Area also, yield, cost of the cultivation, cost of the water, all this has been analyzed. And some of the constraint has been considered in this: irrigation demand constraint, land availability constraint, water availability constraint, crop area constraint, and it has been designed in different, like based on the irrigation water supply, include 5 zones. So zone having the irrigation water supply more than the 100 billion cubic meter, that is in the zone 5, and the least is less than 25 million cubic meters. So that way we have designed for this study area. And these are some of the, at the zone wise, we have also considered monsoon, winter, summer season. And similarly for the dry year, we have, that is a scenario 2 for a dry year, normal year, as well as dry year. And again, we have also considered the dynamic groundwater resources using the surface water during the normal year. So using that, it can enhance much amount, which I will be showing in the coming up slide. And again, similarly for the dry year. So using the dynamic groundwater resources and surface water. So this is the scenario which we can see here. Even using the scenario in the scenario 1, 2, 3, 4. So consider, we are comparing with scenario 1 and 3 and 2 and 4. So here, in case of the optimal crop area, it can increase with the existing with the more than 200%. For optimal irrigation water, it also can increase more than 200% by optimizing the resources. And net benefit is, in case of the scenario 3, it is almost double, and in case of scenario 4, it is more than double. So that way, and this is how the net benefit can be. From the scenario 1, the net benefit is the 24,818 million rupees. In scenario 2, that is during the dry year, it's a drought-like situation, that is the 14,679 million rupees. Scenario 3, that is the with this existing surface water and available dynamic groundwater reserve in the normal year, it has increased almost double, that is 48,769 million rupees. And in scenario 4, that is existing surface water supply and dynamic groundwater in the dry year, that is it can increase more than double, that is 39,158. That way we can also, its optimization is also very important to fight drought like situation as well as flood situations. From this, I have also published another paper, that is the Journal of Cleanup Protection, which is impact having more than 9. That way, thank you. Any question?
Thank you, sir. Thank you, Dr. L. Kanta Singh. He is
Yes, sir, yes.
delivering lecture on various excellent lecture on soil and water management in disaster affected areas, including contour bunding, bench terraces, gully blocking, rainwater harvesting ponds, check dams, and approaches for groundwater by GS, and various aspects, and publishing many papers in reputed journals. Very I appreciating you to deliver a excellent lecture in this program. Thank you for your contribution.
Thank you, sir.
Yes, from participants, if you have any doubt, kindly ask related to this soil and water management in disaster affected areas to Dr. L. Kanta Singh, and he is very excellent. Any questions? Yes. Please, our resource person, Dr. Lala, do you have any discussion? Sir, I have one doubt. Hello? Hello?
Please.
Sir, in watershed areas,
Yes.
in watershed areas, how to manage the water potential in watershed areas for throughout the year, even in the summer season.
Yeah.
So how to maintain the water potential and how to recharge the groundwater.
Okay. For this watershed area, actually, we need to know how to estimate that is for the groundwater, that is the dynamic groundwater. As I have already mentioned in my dynamic groundwater reserve, that is actually the amount of water which we can harvest means without affecting the groundwater resources. There is two. One is the static groundwater resources. One is dynamic. Dynamic, that is the groundwater we have estimated based on the specific yield and the groundwater fluctuation. That is the post-monsoon and the pre-monsoon using that data. So that has to be taken for at least for 10 years data. So that amount of water which we that has to be calculated first. So if we know that amount, then we can safely utilize the groundwater. That is one thing. And already I have mentioned in my which area where effectively we can construct the structure. That is also very important because randomly if we do construct, that will increase our cost of more structure, and at the same time it may not give the effective means like that based on that criteria which I have shown in my presentation. We need to identify a proper place where we can construct a structure that will help not only the recharge the groundwater, it will also control the flood. It will have more for that purpose. Like we need like check dam, we need the percolation tank for mostly for percolation. That is for the groundwater. So first of all, we need to calculate the dynamic groundwater reserve. Once we know that, then how much water we are abstracting means how much water we are taking out from this groundwater. Then again, we need to calculate the whether it is in the critical, whether it is a safe. So in for my study area, almost all the block is giving the safe because the amount of groundwater recharge is quite enough that present existing groundwater draft is quite less as compared, except in few blocks. So that needs to be estimated. Based on that, we has to because our aim is to harvest as maximum runoff during the monsoon because the rainfall will be taking place mostly during the monsoon. That needs to be collected or needs to be harvested at the maximum. So again, the groundwater, because this is a most reliable source of irrigation water supply. So both way we need to know. That's why I have given for for this area for the potential groundwater zoning as well as for this rainwater harvesting. So this both we need to know. Then only we can throughout the year we can maintain the water sustainable water means available for this agriculture or any other sector.
Okay, sir. Thank you, sir. Sir,
Welcome.
there is one question from Anjali Verma. Can all be used in predicting natural incident or disaster? Oh.
Yeah. Yes.
Can AI can AI be used in predicting natural incidents or disaster?
Yes, yes. AI, naturally it can be taken up because even I have tried for forecasting using the artificial neural network or any other AI. It is possible. It is possible, but I have not used in depth. But I have tried, but it is possible. It will give even maybe better result also. We can compare with the existing techniques and using the AI. It is possible. It is possible. It can be for the future study also. It can be used.
Thank you, sir. Sir, in water set areas, suppose the slope and the land slope is more than 2% or more 3%. So in that condition, whether the contour bunding is suitable or any the graded bund is suitable.
Yes. But it is very much suitable. Even up to 15% we can construct contour bund safely. No problem.
Okay. Thank you, sir. So up to 15%, we can go for contour.
Yes, we can.
Any other questions from participant side? Please ask. Madam, Kopal Merma, madam. Hello. Hello.
Yes.
Kopal madam. So I think so once again, I am thankful to our resource persons, Dr. Lala I.P. Roy and Dr. L. Kanta Singh. Today, only 2 lecture. So they are given very excellent lecture on the disaster management in agriculture planning and adaptation of alternative cropping system and soil and water management in disaster affected areas. So I think this lecture helpful for our participant for a future research work also. So in this so tomorrow we'll start again at 2 o'clock. So today program, I think it is going to be end. So I invite Dr. Kopal Verma madam, our coordinator. Madam?
Yes, sir. Thank you. Thank you, sir.
Yes, madam. Please convey some few words, madam, regarding this lecture.
Yeah, thank you so much, sir. So today both the speakers gave very elaborate, very detailed presentations. So I hope all the participants must have greatly benefited by all the lectures. I can understand, I can understand, although some technical glitches were there. So that can be, let go of. So stay with us. I would request all the participants to stay with us till all the 3 days of the training program. We have many more interesting lectures. Very esteemed resource persons and dignitaries will be coming and giving very elaborate lectures. So thank you so much everyone for joining. Thank you to the entire coordinating team from Vishwa Bharati University as well. They have done a tremendous job. So thank you so much everyone for joining, and we're looking forward to have you all tomorrow as well. Thank you so much. So Kandaswamy sir, I think we can close the session for today. So on the chat box, somebody is writing feedback link. So the feedback link will be there available on the training portal from where you have registered on the last day of the training program itself. So and attendance is being recorded, so don't worry. It will be available on the last day, feedback link and certificates and all. So don't worry. Yes, sir, you can continue.
Okay. Thank you for and participants. So we will come to it. So we will talk about program today. So I think today, tomorrow we start at PM. Thank you.
Thank you so much, everyone.